Okay, we're getting ready to do the machining for Rob Stone's hinge plate. This is the original drawing of the slotted plate and the original drawing of the up and down plate that holds the two cam rollers. This is where the drawings came from. This is my CAD cam mounted on my computer. In order to program these, I had to change the drawings a little bit. As you can see, I put the origin in a different spot on both of these drawings because this is the way the parts will actually appear on the machine. Here's the CNC mill that we're going to make the parts on. As you can see, it's an older vertical type mill, and the controller is an old LCD type. It's kind of old, just like I am. Okay, the first step to machine these parts is to actually cut the material that Rob sent me. This will be cut into two pieces. These will be the two upright pieces. Okay, we're ready to start cutting. You can see I've got a mist coolant, and I'm cutting this piece exactly in the middle into two pieces. Okay, we got the first piece cut in two. Now we've got another piece that we've got to cut into two pieces that are 8 1/4 inch or 8 3/4 inch long, and then we'll have a little bit of waste on the end. Okay, from this piece we need to cut two pieces that are 8 3/4 inches long, so we measured that out and set the work stop so that both pieces will come out about the same. This doesn't have to be exact, it just has to be close. If it had to be exact, we'd leave maybe 1/4 inch extra stock and true it up in the mill and get both pieces exactly the same. In this case, all we have to do is get them close because they're not really a critical dimension. Okay, that finishes the second piece, and we have a piece of scrap left over. We also have a piece of 1/4 inch plastic that's about a little over 26 inches long by 8 inches wide, and it has a pretty square cut on this end of the piece. So what we're going to do is use the table saw to cut two pieces off of this squared off end that are going to be 5 inches by 6 inches. So we'll have to make about 4 cuts to get that. That gives us two pieces that are 5 inches by 6 inches and 3 pieces of scrap. The next thing we do is to deburr all of the metal and plastic pieces we've cut thus far. I want to get rid of all the sharp edges to make things easier to handle, and we'll do that by just touching each edge lightly on the disc sander. as we get ready to machine the parts, we have to figure out how we're going to hold the work. We'll do that in the vise, and we've got parallels mounted to raise the part up where we need. For the slot plate, we have a 1024 tap with corresponding tap drill and a center drill, number 4 center drill, and a 1/2 inch drill for the start holes for the slots. The actual milling of the slots and the ends of the pieces, the radiuses and all that, and in the metal and in the plastic, will be done with a 4 flute 1/2 inch end mill. And then in the vertical plates that will hold the cam rollers, we have to machine with the mill to get the rounded edges, and also we'll have to drill and tap for 3/8 by 24 tap size. So what we have to do is put in all the tooling and find the lengths of it, and then we'll actually get into the programming of the machine. The tooling is now all mounted in quick change adapters, and that's tool 1, 2, 3, and 4. We're going to use 4 tools. The tapping I'm going to do by hand after the program has run. That's the quick change wrench for the quick change adapter. We've got the part located in the vise, and I've got a tool stop set so that both pieces will come out the same. Use the longest tool to find the height off of the work. What we do is bring that longest tool over the part, and I use a 1-inch block to set the height, and I do that with the table by raising it up and down, bringing up the work just touches. Okay, and then we have to set the dial at 0. So that's our reference on the table. That sets the work height of the part in relationship to that tool, and that tool will be given a 1-inch offset. Then all the other tools are put in order and touched off to the part, and their offsets are recorded in the controller. I can actually write the program either on the controller, it's a conversational programming setup, or I can do it on the computer and transfer it over the RS-232 feed. But since this is a pretty user-friendly controller, I'm probably just going to program it right here at the console. I've already started programming some of it, and what you see right there is the first line of the program, and the 1001 is for the tool length offset for tool 1. The next line in the program calls for a Z length of minus 1.7690. That's the length of that tool. That's programming for setting the offset for number 2, and that is the offset value. That's setting the offset for tool number 3. That's the offset value. That's setting the offset for number 4, and that's its offset value. The next thing we do is tell it tool 0 to remove all the offsets and give it a Z0 length. And in this case, I got an end to the program, but this is where I'm going to start on then and continue the programming. Okay, we're all programmed now and ready to start running. We've got the first tool in place and everything's ready to go. We'll turn on the spindle and we'll turn on the mist coolant. Take it from manual to automatic and press the start button. Okay, first tool is ready. Here we go. This will be drilling a series of holes. The start holes. Adjust the coolant a little bit. These have just a little camper at the beginning of the hole to let the tap start easier when they get into the manual tapping. Okay, that's number 14, the last one of the start hole. Now we'll go back to the tool change position. And I have to stop the spindle and change the tool. Okay, we got the tool changed. We need to turn the spindle back on. Whoops, got the lock on. There, now I got the brake released. Forgot to do that. And we have to run this tool a little faster. We're set right now at about 1200 RPM, and we need to be running about 2000. So I need to speed this up a little bit. Okay, got the coolant on, should be able to hit the start button, and away we go. Now this is just going to drill the holes that we're going to tap. This is a step drill process because it's such a small drill and we're drilling all the way through the plate. It advances 150 thousandths on each peck. This hole's done, going to the next one. That finished drilling all the small holes. Get us some chips here so we can see what we're looking at. Now we're ready to drill the two big holes in those two spots for the start for the end milling process. We'll do this with a 1/2-inch drill. Okay, now we'll drill the two large start holes for the slotting process. All the 1/2-inch tools run at about 700 RPM. Our surface speed for a high-speed tool in mild steel like this is about 100 feet per minute. So we have to calculate the speed for all these, and then the chip loads will vary a little bit. Usually we're running a chip load around 1,000 to 1,500 per cutter. And here we go. Two holes here. Larger drill puts out larger chips. Okay, we got 2 start holes. Okay, we're getting ready to mill the slots and then around the corners. And since this throws so many chips, I usually put up a kind of a temporary barrier here. So got the coolant going, should be ready to push the start button and away we go. Using a 1/2 inch diameter cutter to mill a 3/4 inch wide slot. That way I can control the width of it. I'm trying to cut it about 5 or 6 thousandths oversized. So we'll see what it ends up with. To finish the first pass, it'll take 20 passes, each time taking 26 thousandths of an inch in depth. Goes to center, down feeds, and starts again. Just keep doing loops on this same process for each slot. Okay, I stopped it after 2 passes. I think we got enough there. I can check the width on this roller. It's got just a little bit of clearance. Pretty nice fit, really. I believe we're going to be okay at that size. Okay, we'll turn it on and start it back up. Take it out of single stop, go back to automatic, hit the start button, and have to hit it twice. And here we go, milling some more on the slot. We're halfway through on the first slot. Halfway to depth. So we got a nice pile of chips. Looks like it's cutting real nice. We have the slot. Now we'll clean it up and check it for size. Measures about 10 thousandths clearance. Looks pretty good. I actually programmed it for 6. And it's not really too sloppy. We need just a little bit of movement, but it rolls very nicely along either side. I think that'll do fine. On to the second slot. Hit the go button and we're ready to cut. Starting on the second at 20 passes on the curve slot. Okay, that finishes the milling on the first plate. All we got left is the hand tapping and the deburring. To hand tap the parts, I just moved the machine over the hole according to the coordinates in the program and use a tap driver that's a hand tap driver that's guided by the chuck. Pretty simple process, just takes a little longer than doing it by machine. Okay, we're ready to start the second piece just like the first one. We got it located in the vise. We got brake end mill cutter in the tool holder here, and we're ready to go. Same program as before. So we'll hit the start button, and away we go. Starting the second piece. Just peel it a little bit. Drill a series of holes. The second piece is now done, along with the first piece, and try to get a close up here so you can see this one still needs to be deburred. Got sharp edges on the holes and on the slots and on the corners. The first one's been all deburred. It's ready to go. And even got screws in some of the holes. So the next step will be to cut the plastic pieces. In order to machine the plastic, we need to stiffen it up. So I will put a board under it and hold it in the vise. We put shoulder parallels in to accommodate that. We're going to use a 82-degree countersink to start the holes, and a 3/16 through hole for the screws, and then a 3/4 inch aluminum cutting end mill, which will work real good in the plastic. It's a 2-flute, and we'll change the program to accommodate the plastic. It'll be a little simpler program, and the program that we did the steel parts with is now over in the computer, and where it'll be stored. We can only have one program at a time in the controller, and we've got the plastic program in there now, so I think we're ready to set the part in place and start cutting. Cutting the series of holes for the screws, putting the countersinks in first, then we'll come back and drill the holes, and then last will be the slots and round the corners. Okay, now we'll drill the holes straight through. Holes are now all drilled and countersunk, and we're ready to start drilling the slot. lot of snow on there with a little bit of sawdust mixed in it. Just going back and forth on that radius with a down feed at each end. Okay, there's the finished right-hand slot plate and shim plate fastened together. With the screws, looks like the countersnakes come out real nice and everything fits pretty good. Now we'll do the other shim plate for the other side, and it'll have to be a mirror image of this one. So what I do is go to the controller and just put in a couple of simple commands to make a mirror image. We also have to change the origin from the corner down here to up here, because we were working in the first quadrant. By using the mirror image, all of the y-axis coordinates reverse sign. So now instead of working on this side of the part, we're going to be working from here as y0. So the two things we have to do is to put in the mirror image and change the origin for the part. And it should be ready. We're starting on the opposite side of the part. So this should give us a mirror image. Instead of working in the first quadrant, we're working in the fourth quadrant. Okay, that finishes the machining for the second shim plate. Now we need to get it out of there and clean it up and deburr it, and it'll be ready to assemble. In order to deburr the parts, the slots, I use a deburring tool and do it by hand, and we'll power deburr the holes, and the edges we'll do on the disc sander like we did before. I like to mount the part that I'm going to deburr in the vise, and because this is a sharp tool and can slip, I usually use gloves. It's just a matter of going around the edge of the hole with the deburr tool. It's got that slot. The curved slot's just a little bit more difficult. The inside curves aren't bad, it's that outside curve that's kind of tricky. Wants to dig in. Well, that pretty well got rid of the burrs there. For the holes, I just use a 90-degree deburring tool. Now that does throw just a slight burr back down into the threads, so I'll have to chase each one of those holes a little bit with the tap, but that'll be pretty easy to do. The plastic piece gets pretty much the same procedure on the grooves. I just hold this by hand because the plastic cuts pretty easy. These burrs won't really catch on the plastic, but we do need to get them out of the way. Get over and do the other side. Edges don't feel bad on the plastic. Most of it will just pick off with your fingers. We've now got a right hand and a left hand slot plate made, cleaned up, ready to go with the shim plates installed. And got to looking at the way this roller fits in here. You can see the threaded portion doesn't run all the way down to the shim plate. If we set the half-inch plate up here that we're going to have to machine, you can see that the plate's going to have some relief put in it. It's a little better angle to see what I'm talking about. The full 3/8 inch diameter of that stud sticking through there is going to go about halfway through the half-inch plate that it screws into. So I'm going to have to make a bushing and then countersink the hole in this plate before I thread it. And then it'll only thread into about the back half of the plate. This way I can still get a good alignment on the part and have a spacer to take up the part in between there, the space in between. What I'll do is make a step spacer. I'll use this 3/8 rod and drill it and counter turn it, put a shoulder on it, and like I said, 3/8, that's a 3/4 rod, and then I'll turn down a 9/16 counter bore, the part that fits into the counter bore, and then it'll have a 3/8 hole all the way through for the stud to actually fit in. Maybe it'll make more sense when I actually do it. I've got the 12-inch piece mounted for the upright hinge plate that the studs are going to be mounted in. We're going to drill and counterbore some holes and round the ends, but I think we'll round the ends up on each piece after we've already done the counterbores to keep the cutter sharp a little longer. Program's all in and loaded. I think we're ready to go. There's the 2 start holes. That'll be the locations for the studs, the roller studs. And now we're ready for the through holes that will be the tap size. Okay, we switched to a 3/8 end mill. It's a carbide end mill, so we can run higher feeds and speeds than we could with a high-speed steel. But in order to try to hold the edge on the tool, I'm just going to do the 2 counter bores, and then we'll do the other piece, and then we'll come back later and do the corners. So we'll try to keep our end mill sharp. I think we're ready to go. I decided to go to a 5/8 diameter on the counter bore instead of a 9/16. I think it'll work out a little better, and the mill operates a little smoother with the bigger diameter. Okay, we have a 5/8 counter bore halfway through the part. The bottom half of that hole will be tapped for the threads on the stud of the cam roller. And took a measurement on this. Looks like we're about 2 thousandths oversized. So when I make the bushing, I'll go about 3 thousandths oversized and get a light press fit on it. Okay, now we'll do the second counter bore. Doing a circular interpolation with a dam feed in the center of the hole, and 25,000 depth each time for a total of 10 times around. Okay, I pulled the first piece out, and we got the second piece loaded in there. We'll do the holes in the counter bores, and then we'll come back and do the rounding of the corners on both pieces. We're back to the beginning of the program. We should be ready to go. Pilot for the first hole. Okay, we got 2 more counter bores. Now we're ready to do the 2-inch radius on the 2 outside corners here. is going to go back and forth across the radius and cut a piece of material off. Anytime you're cutting the full width of the cutter, it puts a little more stress on everything, and so I wanted to do those counter bores before we did this operation. Okay, we've got one more pass to go, and just to make sure that we're cut all the way through, I'm going to raise the table a turn, which raises it up about 100 thousandths. Now it should cut cleanly through the parts. Put back in automatics and hit the go. There should be a piece come flying off of there as it gets part way around. There it goes. Now I have a radius. Okay, I'll put the table back in position and we're ready to cut the last radius. By using a smaller diameter carbide cutter, I can speed things up a little bit. We now have both corners radiused with a 2-inch radius, and before I pull that part out of there, it's all located and in position. I'm going to go ahead and tap it, and then we'll put the other part in and finish it up. Well, that plate is all finished now except for the deburring. Got it all counterbored and drilled and tapped, and the radius is on it. Just need to deburr it, and we'll put the other part in there and finish it up now. The last piece is in and tapped, and we're ready to put the radiuses on. And that'll be all of the mill work, and we need to make some bushings on the lathe. That's the last piece off the mill. That concludes the mill work. Now all we've got to do is deburr, make bushings, and assemble parts. Now we need to make a stepped bushing or spacer, kind of looks like a bushing, to fit in the plates that we just finished to go in the counter bore where the rollers go, and we'll do it on my little 10-inch South Bend manual lathe. We'll make it out of this 3/4 inch rod, and I'll chuck it up here and we'll get started on it. Okay, 2 passes cleaned it up pretty good. Now we need to change tools. We got to put in the turn tool and take out the facing tool. Now we'll turn down a 5/8 diameter for a 1/4 inch in length, and then we'll leave the 3/4 on the rest of it and part it off at 1/2 inch long. we also need to drill a 3/8 hole through the center of it before we part it off. Have a dial indicator mounted on my movable carriage stop. What I do is bring the tool up till it just touches the part and set the dial indicator at 0. Then I can back the tool away from the part and can then rotate the dial indicator by moving the part until I get 1/4 of an inch. There's 200 thousandths, and at 50 will be at, there we go, 1/4 of an inch. Now I set the work stop there and just machine up to that point each time, and that'll give me a 1/4 of an inch counter turn on the part. Okay, I made one pass and got size on the machine and set the dial. So we're ready to take another pass, and this one will be at it should be exactly 0.7 diameter. Stop the machine and check the size. Okay, looks like we're maybe 1/1000th undersize. So we'll readjust the dial by 1/1000th of an inch. That should put us on size. We can go ahead and take it down to 6.3. I'm going to leave a couple of thousandths interference fit. Okay, I've got it turned down to exactly 6.30. That's the size I'm shooting for. Now we just need to put a little corner break out here on the edge and drill the hole in the end and part it off. Now we'll run the center drill in to get the hole started in the center of the part. And as soon as we get that done, we'll go back with the 3/8 drill and take it to depth. Trying to hold the camera and run a manual mill at the same time is lots of fun. I couldn't get the tripod set to work where I wanted it to for this operation. Okay, we got the 3/8 drill installed in the tailstock chuck, and we'll drill about 5/8 of an inch deep to get us deep enough to get through to where we're going to cut it off. Okay, I've got the end of the part all deburred, and we're getting ready to do a part off, and it's starting in right here. I'm going to actually part it off about 25 thousandths long, and then turn it around in the chuck and face the end of it. Because the part off tool never leaves it really totally smooth and accurate, so we can face it off after it's cut. Just leave a little extra stock on there. Okay, we're cutting off the part, and I got the rod in the end of the tailstock to catch it when it parts off, and it won't fall down in the chips below. Then when it's done, we'll have to face off the other end and deburr the end where it's parting off there. When that one's done, we'll do 4 more. Correct that, 3 more for a total of 4. Okay, there's the first spacer cut off. About 25 thousandths too long, and the surface is just a little rough from a part off tool. And I've got a sharp edge there, so we'll have to put that back in the chuck the other direction, like that, and face it to length and deburr the edge and the edge of the hole. We've got all 4 of the spacers made. It's basically what they look like, and they will fit into the counter bores. And I'll put them in the press and press them in. I should have a light press fit. and we should be ready to start assembling. Okay, here's my homemade press. It's just a bottle jack in a frame that we welded together with a reservoir on top. I do have a little leak here in my connection, so I have to put a drip can under it, but anyway, we'll adjust this down and see if we can press these bushings in. Get centered up on the valve and see if we can get it to press in. Okay, nice fit. Got one in. Now the next one. Just a very light press fit. Now we'll do the other plate and we'll be ready to install parts. Here's the two slot plates with the plastic shim installed, and here are the two vertical hinge plates with the roller studs installed. And we've put jam nuts on the back side to help hold things in place so that it won't come unscrewed in operation. Okay, the parts go together like this. This would be the one on the left hand side of the vehicle, and back off here a little bit. That would be the fully closed position. That would be the fully open position, or rather the end of the forward travel, and then it goes into the tilt. That will be the tilt position. We do have just a little bit of play, as you can see, in the linear portion of the slot. So we're probably going to have to put a special design on the mechanism that opens and closes this to compensate for that.